All right, so in this video, we're going to talk about taking those newer trig graphs and now transforming them similar to how we did sines and cosines. So the first thing I'm going to do is go ahead and get the graph of tangent on the screen. And for the fundamental cycle of tangent, from negative pi over 2 to pi over 2, counting by pi over 4 intervals or units. So both directions. Those asymptotes were at negative pi over 2 and pi over 2. And then if you remember, the graph looks something like this in between them, where that was at 0, that was at negative 1, and this one was at 1. So there's the parent function for tangent of x. Now, we'll go ahead and we'll take the x minus pi over 2, and now we're going to bound that between negative pi over 2 and pi over 2. For sine and cosine, it was always bounded between 0 and 2 pi, but again, now we're starting with a different fundamental cycle, negative pi over 2 to pi over 2. If we add pi over 2 to both sides, we'll end up with a 0 less than x less than pi. So that's what I'm actually going to graph now for the true example number 3 that we're looking at. So we start at 0, we go to pi. We know there's going to be 5 tick marks. So 1, 2, 3, 4, 5. This one's pretty easy. If you see, we start at 0 and we go to pi. If we divide that by 4, we get a pi over 4 on each interval. So pi over 4, pi over 2, 3 pi over 4, and then pi. And then it's actually pretty simple. You can see that the asymptote will be on the first tick mark and the last tick mark. So that's what I'll do in this graph. First tick mark and the last tick mark. I also know that the middle tick mark is going to be at 0. I don't have any vertical shift, so the middle tick mark in my new graph is also going to be at 0. And in the parent function, we started low and we ended up going high, so we had an increasing function. But the negative here flips it around the x-axis. So now, instead of being an increasing function, it's going to be a decreasing function swooping through in this manner. So I'll go ahead and see if I can sketch that in. And my point here at pi over 4 would be the 1, and my point here at 3 pi over 4 would be at a negative 1. So there's the graph of negative tangent of x minus pi over 2. All right, so a couple follow-up questions. The asymptotes. Now, the asymptotes, you can see pretty clearly, they're not difficult to put together in this particular one, but I do just want to give you a brief rundown on how to do this in case they are a little messier. So what you would probably want to observe is from the original, the asymptotes were at x equals pi over 2 plus k pi. Now, that's the original graph. Our graph is x minus pi over 2 instead of just an x. So I'm going to replace the x with x minus pi over 2. And if we go ahead and put this together, if I add pi over 2 to both sides, well, now the pi plus k pi gives us just a k pi. These are going to be our new asymptotes. So again, what I did here is I took the old asymptotes and I replaced the x with the new angle from right here. And then if I solve it for x, that's always going to give us the new asymptote. So on these more complicated ones, that's a good method to use. So x equals k pi. The range would be negative infinity to positive infinity. In the period, the distance required to complete one cycle we're now at 0, we go to pi, so it looks like the period is still at pi. And that kind of makes sense up here. You don't have a b sitting in front of there, so our period is not going to be adjusted, so it's going to be back to the original. All right, so the last graph we're going to look at is 2 cosecant of 3x. As always, we're going to go ahead and start with just the graph of the parent function. For cosecant, that's going to be, again, the reciprocal of sine, which has a period of 0 to 2 pi. So now we're back to the pi over 2, pi, 3 pi over 2, and 2 pi. Anywhere that sine is 0, that's where you're going to have the asymptotes. Sine would be 0 in these 3 places. And then the actual graph, if you remember, would look something like this. So that's going to be the graph then for cosecant. Now, we'll go ahead and we'll take the 3x, and I'm going to bound it between 0 and 2 pi. When I divide by 3, I get 0 less than x less than 2 pi over 3. So our new graph will start at 0, and we'll have 5 tick marks, 0, 1, 2, 3, 4, 5. And our last tick mark will be the 2 pi over 3. Now, the period here, the distance from start to finish, is 2 pi over 3. So if I take the 2 pi over 3 and I divide it by 4, that's going to give me a pi over 6. So each one of these is pi over 6 units apart. So 1 pi over 6, 2 pi over 6, 3 pi over 6, and then finally 4 pi over 6. If we look at the graph of the parent function, the asymptotes are going to be the first, the middle, and the last. So I'll come over here, the first, the middle, and the last. And there's no vertical shift, there's no reflection either, but we do have an amplitude of 2, which just means that instead of having 1 and -1, which I didn't mark over here and I probably should have, we're going to have a 2 and a -2 because of the amplitude change. So for the first region, we're opening high, and for the second one, we're opening down. And so there sits the graph of 2 cosecant of 3x. The asymptotes, kind of like what I was telling you before, if you can see them, great. If you can't, it's not a big deal. We can always take the original asymptotes, which would be x equals k pi. We could then substitute a 3x for the x. Notice we started at x and then we changed to 3x, so 3x now equals k pi. Therefore x equals k pi over 3. And those would be the asymptotes for the graph that we have up on the screen. So x equals k pi over 3. The range, be a little careful here, -infinity to -2 inclusive, union 2 to positive infinity. And then the period, as I mentioned just a moment ago, since we start at 0 and we finish at 2 pi over 3, the period would just be the 2 pi over 3.